how to convert the decimal to binary. Okay, how to convert the decimal number in the binary number. In the first step, we have to divide the decimal number in the basis of 2. That's the base of the binary number. That's mean 2 is the base of binary number, so we have to divide it the decimal number in the basis of 2. Okay, next we have to collect the remainder. Okay, we have to collect the remainder in the of the first step. Okay, that means in this you can see the example. 225 is divided by 2 and the remainder is 1. Divided the 12 by 2 and it produces remainder 0, so it's take it separate. And we have to divide the 6 by 2, it also produce a remainder 0, so take it separate. We have 2, we have 3, that's we divided by 2, it's produce a remainder 1. And we have 1, it's divided by 2, it's produce a remainder 1. So we separate all the remainders. Next we read the remainders column from downwards to upwards, that means in backward directions. Okay, we have to read the remainder column in the backward directions, that means downwards to upwards. Okay, here you can see we collected the remainder as 1 first. That means we goes from down to up, we have goes from down to up, so 11001, that's the answer. That means if we convert 25 to an binary number, that means it's equal to the 1101. Okay, next, how to convert a decimal to binary in form of fractions. Okay, if there is a fractions decimal number, so how to convert it? Okay, in case of fractional decimal number, multiply it by 2 and record the carry in the integral positions. Okay, let's when in case of that, in this example we take it, a decimal fraction that is 0.35. At first we have to multiply it by 2, that's produce 0.70, and its carry is 0 because their integral positions are before decimal point is 0. Next, if we multiply 0.70 into 2, it's produce 1.40. That one is carry forwards. Okay, that's we have to separate that one. So next, if we separate the one, so we leave the positions after the decimal point positions, that's 40. Next line we have to multiply it by 2, that's produce 0.80, and the carry is 0. And if we multiply 2 with 80, it's produce 1.68. That's one is carry forward to the remainder column, or maybe in the carry forward column, you can say as it is. Next, 1.6 into 2, it's produce 1.20, that's one is goes to the carry forward column. Okay, here you have to read it, you have to read it upward to downward. That means before decimal point you have to divide it by 2 and read it upward. Okay, downward to upward. Decimal point, that's number we have to multiply by 2, and the carries are read upward to downward. The carries are read from upward to downward. Okay, in case of that, you have a questions like that, how many times we have to multiply it. Okay, there's two possible cases to terminate these multiplications, like that if you see that there comes 1.00. Okay, in this case, okay, you in there is 0.50 cross 2. that's produced 1.00. In this case the multiplication is terminated. Okay, in this case the multiplication is terminated. And another way, that is, if you seen that the similar pattern is executing more than one time. Okay, that means in this case you can see is 4.00 into 2, and this, and the second thing is 8.80 into 2. In the second line, if there is a 4.0 into 2, and the very second line is there is zero point 0.8 into 2, you can see that the similar pattern is executing more than one time. So you can stop there and you can take the remainder or take the carry forward column and read it upward to downward, and it's the answer. Okay, next, binary to decimal. How to represent a binary into a decimal form? You can, I try to discuss these things in one example. It's a very popular example. Okay, since we all know the binary number system has two digits, 1 and 0, so its base is 2. So we do all the calculation in basis of 2. Okay, in this case you have to count the positions. Okay, the positions is matters in the binary to decimal conversions. You can see, we take an example 101, sorry, 1010.1011. We take this example, how to calculate it. We can see here is a binary point. Okay, in case of decimal, that point is called decimal point. In case of binary, that point is called binary point. So binary point is our fixed positions. This binary point, the left hand side of this binary point is counted as plus positions, and the right hand side of this binary point and right hand side of this point is called as a minus position. That means the first zero before the binary point is zeroth positions. Okay, and the 1 is the 1 position, and the 0 is the 2th positions, and the last one is the 3rd positions. Okay, and this, after the binary point, the position is -1, and the 0 is the -2 position, and next one is the -3, and the last one is the -4 position. Okay, the position is matter, you have to calculate their positions. Okay, next, you can write, you can see in this example I write here the positions. The 0 before the binary point, the 0 is the 0th positions. So the binary point before the binary point 0 is multiplied by 2 to the power 0, because this 0 in the 0th position, the 1 before 0 is the 1 position. So I have to, or we have to calculate is as 1 into 2 to the power 1, because it's the 1 position, and the second 0 of the okay, in the 3rd position there is 1, so you have to multiply 1 into 2 to the power 3. In the second position there is 0, so we have to multiply it by 0 into 2 to the power 2. In the first position we have 1, so we have to multiply 1 to the power 1. And the fourth positions, or in the 0th positions we have 0, so we have to do it 0 into 2 to the power 0. And after the binary point, the first position is -1, so we have to do it 1 into 2 to the power -1. The second position is -2, so we have to do it by 0 into 2 to the power -2, and so on. And we have to add, we have to sum all the calculations, so we have found the result. Okay, thank you.